Let's do another example. This time, we're going to use substitution to integrate a function, and that function is going to have e to a certain exponent. Notice this exponent is 4x squared plus 5. If we have this situation, then I would say the inside function is the exponent. So I would set the u equal to 4x squared plus 5, and then hopefully this x along with the dx can be substituted in for a du in some way, shape, or form. Let's go ahead and try this. Like I said, in this case, we have the function x times e to the power, and that power is 4x squared plus 5. The inside function is going to be the 4x squared plus 5. That is the function in the exponent. When I take a derivative of u with respect to x, I end up with 8x. That means I can exchange a differential du in for an 8x dx. Now I have to rework this integration in order to make my u and du exchange work. Therefore, I want to take the x and I want to put it back in the back with dx. This gives me x dx in the back. That's very close to what I have. I have an 8 times x dx. There's a couple of ways we can do this, but I think the one that's probably fastest is just to divide both sides in my differential exchange by 8. That is going to give me 1/8 du equals x dx. Once I've done this, now I am set to do my substitution. The 4x squared plus 5 is going to get exchanged for the u. That's what we set out at the beginning. And now I know the x times dx can be exchanged for a 1/8 du. Let's rewrite that. I probably should have been putting equal to signs in front of all these. These are all equivalent integrations. I'm going to take the 1/8 and put that as the coefficient of e to the u. We should all know now how to integrate e to the u with respect to u. The antiderivative of e to the u is e to the u plus some constant. So when I have a constant of 1/8 out front, a coefficient, I get 1/8 e to the u plus a constant. We're almost done. Notice the integration got rid of my du, but I still have a u around here, and so I need to back substitute and replace that u with a 4x squared plus 5, because our integration started with x's and we want to end with x's. We got 1/8 e to the 4x squared plus 5 plus a constant of c. That's how to do this problem. So we saw on our previous couple of problems, the inside functions were the polynomials which got raised to a high power. Now, because we're dealing with an exponential function, the inside function became the function that was in the exponent. That's the idea of substitution with exponential pieces. I would like you to try this problem on your own. Push pause on the video and try to do this problem. On the next video, I will show you how it's done.